Yeah. Yeah, start.
Okay. Edge computing and analytics using the Microsoft Azure. Normally, the edge computing is what? Edge computing allows IoT device to process and add the data in real or non-real time by processing data at the edge of the network. It's allow the device in remote location to process the data at the edge of the network, either by the device or a local server. And what data and when the data needs to be a process in the centralized data center, only the most important data is transmitted there by the minimized latency. Means suppose मुझे डेटा सेंड करना है मेन सर्वर को अगर मैं डेटा सेंड करती हूँ तो मेरा ज्यादा डेटा क्लाउड पे स्टोर रहता है तो वो एक लोकलाइज सर्वर बना देता है जिसपे हम लोग को पर्टिकुलरली जो डेटा चाहिए वो हम लोग सेंड कर सकते हैं। इसके लिए मैंने एक लिंक दी है नीचे यूट्यूब पे जो इजीली समझ आता है कि क्या है ये एनालिटिकल कंप्यूटिंग।
Hmm. So you want to open the link?
यस सर, बिकॉज वो बहुत अच्छे से समझ आता है कि एज
This
कंप्यूटिंग
one,
क्या
this
क्या है।
one.
यस यस।
Okay, so we are opening this link. Okay, and today at the end of the day, I will also talk about the Chat GPT. Now it is working. Okay, so we will
Okay.
discuss that. Do remind me before leaving. Okay. Okay.
Okay.
So now
Yes, sir.
I'm playing this video.
What is edge computing and why it matters? Edge computing is exactly what it sounds like, computing that takes place at the edge of corporate networks, with the edge defined as the place where end devices access the rest of the network, things like phones, laptops, industrial robots, and sensors. The edge used to be a place where these devices connected so they could deliver data to and receive instructions and download software updates from a centrally located data center or the cloud. Now, with the explosion of the Internet of Things, that model has shortcomings. IoT devices gather so much data that the sheer volume requires larger and more expensive connections to data centers and the cloud. The nature of the work performed by these IoT devices is also creating a need for much faster connections between the data center or cloud and the devices. For example, if sensors and valves at a petroleum refinery detect dangerously high pressure in the pipes, shutoffs must be triggered as soon as possible. With analysis of that pressure data taking place at distant processing centers, the automatic shutoff instructions may come.
So Snail, I got the answer of your question that you asked previously, how to connect all the devices. So I think the solution is Azure. Okay. So with the Azure or the edge computing, you can connect all your components with the peripheral that you want. Okay. And
Okay.
And further you can search about that. Okay. So this is, I think, the Azure has the answer for your question.
Yeah.
Okay.
Come too late. But with processing power placed local to the end devices, latency is less, and that round-trip time can be significantly reduced, potentially saving downtime, damage to property, and even lives. Even with the introduction of edge devices that provide local computing and storage, there will still be a need to connect them to data centers, whether they are on premises or in the cloud. For example, temperature and humidity sensors in agricultural fields gather valuable data, but that data doesn't have to be analyzed or stored in real time. Edge devices can collect, sort, and perform preliminary analysis of the data, then send it along to wherever it needs to go, to centralized applications or some form of long-term storage, again either on-prem or in the cloud. Because this traffic may not be time-sensitive, slower, less expensive connections, possibly over the internet, can be used. And because the data is pre-sorted, the volume of traffic that needs to be sent at all may be reduced. So the upside of edge computing is faster response time for applications that require it, and slowing the growth of expensive long-term connections to processing and storage centers. The downside can be security. With data being collected and analyzed at the edge, it's important to include security for the IoT devices that connect to the edge devices and for the edge devices themselves. These devices contain valuable data, but there are also network elements that, if exploited, could compromise other devices that contain stores of valuable assets. With edge computing becoming more essential, it's also important to make sure that the edge devices themselves don't become a single point of failure. Network architects need to build in redundancy and provide failover contingencies in order to avoid crippling downtime if a primary node goes down. The industry has already gone a long way toward addressing the demands of edge computing, and it's becoming mainstream. Its importance is likely to grow even more as the use of real-time applications becomes more prevalent.
Okay, so what in short, what is edge computing? In short, just tell me.
एज कंप्यूटिंग मीन्स अगर मुझे कुछ डेटा भेजना है तो मैं पहले एक लोकल सर्वर को भेजती हूँ डेटा, जो लोकल सर्वर सब डेटा कलेक्ट करके बाद में मेन क्लाउड को भेजता है, जहाँ से ट्रैफिक रिड्यूस होने के लिए वो एज कंप्यूटिंग इम्पोर्टेंट रहता है.
Okay, and is the security essential in edge computing?
Yes.
Okay, because if it is not secure, then it will not be connected. So it is
Will
again
not be
related
connected.
with the Azure that Akash told. It is again, I mean, this in our last assignment. So it is everything related to the Azure cloud and the Internet of Things. Okay.
Yes.
So okay, and continue. So what else you want to present? This is how does
एज
computing work?
computing means same video like that, connecting
Yeah.
the network to remote location and that. Edge analytics. Edge analytics is an approach to data collection and analysis in its which an automated analytical computation is performed on the data at a sensor, network, switch, or other devices instead of waiting of the data to be sent back to the centralized data store. Uh, how is edge analytical used? One of the most common use case of edge analytics is monitoring edge devices. This is particularly true for the IoT device. A data analytics platform might be deployed for the purpose of monitoring a large collection of the devices for the purpose of making sure that the devices are functionally normal. If the problem does occur, an edge analytics platform might be able to take the corrective action automatically. If automatic remediation isn't possible, then the platform might instead provide the IT staff with actionable insight with the help of the fix the problem.
Okay, great. If if the server is not able to automatically access the problem, then the IT staff
Then
will do the problem.
IT staff will go. Yes.
Like sometimes your network issue is not going on.
Yes,
So
server
you
is
call,
not working. That
yeah. So in that case, you call the customer care or something like that. So it is
Yes.
the IT staff will handle the care. Okay.
This is the
Benefits of
benefits of edge
analytics.
analytics. Server.
Near real-time analysis of data, because analysis is
Because the
performed
analysis is performed near the data, often
near
on
the
the board of the device. Yes. The data can be analyzed in the near real time. This would simply not to be the case if the device has to transmit the data to the back end server in the cloud or in the remote data center for processing. Scalability. Edge analytics is by its very nature scalable because each device analyzes its own data and the computation workload is distributed across the devices. Okay.
So it is very well distributed. The work is very well distributed.
Yeah, distributed. Possible reduction of cost. Significant costs are associated with the traditional big data analytics, regardless of whether the data is processed in the public cloud or in the organization own data center. There are the costs tied to the data storage, data processing, and the bandwidth consumption. Some of the edge analytics platforms for the IoT device use the IoT device hardware to perform the data analytics, thereby eliminating the need of the backend processing. Improve security. If the data is analyzed on the board, the device that created it, then it's not necessary to transmit the data, full data set across the wire. This can help improve the security because the raw data never leaves the device that created it.
Okay.
This is a small diagram for the sensing data is going to the edge analytics.
So this we
For
all
get to the
understood up till now. These are the end devices. This is the
end
gateway.
devices,
This is the
gateways,
channel. This is
and the
the
data
cloud.
flow and the
This cloud is the
yeah.
Azure, and this is the data center.
Yes, yes.
Okay, great. Now again, edge analytics
Yeah,
versus edge computing.
versus edge computing. Edge computing is the base of the idea that the data collection and data processing can be performed near the location where the data is either being created or consumed. Edge analytics use these same devices and the data that they have already produced, and analytics model perform the deeper analyze of the data then that was initial performed. This analytics capability enables the creation of actionable insight, often directly on the devices.
Okay, so this is the analysis and this is the computing. So these almost the
Computing.
same thing. The without computing,
Yes.
you cannot do the analysis, and without analysis, the
Yes.
computing is not complete.
Yes.
Okay. So both of you did well. You also did well. So this is the I'm stopping the recording over here. Now we will just give me 1 minute.